Hello everybody. This tutorial will consist of two parts, and it will be about the binary system. So this is the first part of the tutorial about the binary system. Now, to understand the binary system, we will start by talking about the decimal system. So the decimal system is based on powers of 10, and it has numbers, single-digit numbers that are ranging from 1 to 9. Now, if we wanted to express numbers that are larger than 9, what we do is we do this through places whose values are at powers of 10. And what I mean by that is, these are the places that I mean. Let's say that we want to express number 12. 12. So to do that, what we do is we put 2 in the units number. I'm going to call this the units place. We'll call this the units place. This one here. This second place is the tens place, or this place is at the value of 10 raised to the power of 1. So on this place here has a value of 100, or 10 raised to the power of 2. So if I wanted to write 12 in the binary system, I would put 1 here, 1 in the place whose value is 10 raised to the power of 1, and 2 in the units place. That would give me 12. If I wanted to express the number 112, all I need to do is to put 1 in the place whose value is 100, or 10 raised to the power of 2. So that's how we write 112. Now, this is essential to understand how the binary system works. If we talk about the binary system now, the binary system is based on powers of 2. So, binary. Binary system has only 2 digit numbers, 1-digit numbers, which is 0 and 1. If I wanted to express numbers that are larger than 1, I will need to use places just like these places, but these places in the binary system are at powers of 2. Let's take an example. So again, this very first place, we'll call this the units place, and this second place will be will has the a value of 2 raised to the 2. Oh, I don't know why it's doing this. 2 raised to the power of 1, and this one here, this place will have the value of 2 raised to the power of 2. If I wanted to express 1 in the binary system, I'll put 1 here in the units place. If I wanted to express number 2, well, there is no symbol in the binary system that expresses number 2. So all I need to do is to put 0 in the units place and 1 in the 2's place, or 1 in the place whose value is 2 raised to the power of 1. So this here is number 2 in the binary system. If I wanted to express number 4 in the binary system, I come have a look here. This place here, this place value is 2 raised to the power of 2, which is 4, I'm sorry. So I need to put 0 here, 0 here, and 1 here. So that is 1 in the 4's place, or 1 in the place whose value is 2 raised to the power of 2, which is 4. So as a rule of thumb, if we wanted to, what if we needed to know the value of any place in the binary system? So if these are all places, let's make them 8. 1, 2, 3, 4, 5, 6, 7, 8 places. As a rule of thumb, the value of any of these places, we're going to call this, let's say V, is equal b raised to the power of n minus 1. Oh my god, what does that mean? So b here means base. So the base is, in the binary system, is 2. N is the rank of this place. The rank is like this place here, its rank is 1. This is 2, this is 3, this is 4. So like the example that we used here, this was the third place, 1, 2, 3. So this place is this right here. If we wanted to know the rank of this according to this equation, we're going to say, okay, the value of this place is base 2 on the binary system, and its rank, that would be 3, 1, 2, 3, 3, minus 1. That would be 2 raised to the power of 2 to the power of 2, and that would be 4. So now we know that the value of this place is 4. That's verified. If I wanted to know the value of this place, which is the 8th place, that would be, okay, 2 raised to the power of 8 minus 1. That would be 2 raised to the power of 7. Whatever that would be. Okay, so now that we know all about the values of the places, we're going to take this opportunity to convert a binary number to its decimal equivalent. And it's very easy to do once you understand this here. So let's say we have this number right here in binary notation. Now this, by the way, this is called unsigned binary notation, the system that we're using here, because binary systems, they have many notations. So the notation that I'm talking about here is unsigned binary system. No, let me write it down. Unsigned binary system. Okay? Okay. So let's say, let's get rid of this. Let's say that we want to convert this number to its decimal equivalent. What you do is you add up all the ones now that you know the rank of its places. Let me remind you, okay, each place is 2 raised to the power of this place minus 1. So this place value is 1, this place value is 2, this place value is 4, I'm sorry, this place value is 8. How do I know that? Okay, this is 2 raised to the power of 1, this is 2 raised to the power of 3 minus 1, that would be 2. This is 4 raised to the power of 3, that would be 8. So I have 1 plus 4, 1 plus 4 plus 8, that would be 13. So this number in binary notation is 13 in the decimal system. Very good. Okay, one last thing, and this tutorial will be to reach the end of this tutorial, which is now we need to do the equivalent. We need to convert any number. We need to convert any decimal number to its binary equivalent. Now that we know how to convert a binary number to its decimal equivalent, we want to convert decimal to binary. So here's how we can do this. We'll follow a very simple algorithm. So first, in 3 steps. Divide this decimal number, divide this decimal number, which is x, by 2, okay, and record the remainder. Don't worry, I'm going to give you an example. Okay, you will keep doing this till the quotient is less than 2. Then you will pass this quotient, you're going to pass it as the last remainder, and then you are done. Number 3, your binary representation is all the remainders from the bottom up. Okay, that sounds a little bit mysterious, but once we see the example, it will be a piece of cake. So let's take an example. Let's say that we want number 13, the number that we used in the previous example. We want to convert this to binary. So I'm going to write here Q, which is quotient, and here is the remainder. So we'll divide this. Here's the algorithm. Okay, divide the number by 2, record remainder. So 13 divided by 2 is 6, and remainder is 1, because 6 times 2 is 12, so we still have 1 to get 13. Okay, and then we repeat this again. So 6 divided by 2 is 3, there is no remainder, put 0. Pass this here. 3 divided by 2 is 1, and you have 1 as a remainder. Why? Because 1 times 2 is 2. You still have 1 to get to 3. Now, pass this here. We are always passing the quotient. Pass this here. Now, 1 is less than 2, which is the base. So, to get back to here, as long as when the quotient is less than 2, pass the quotient as the last remainder, and then you're done. So we're going to follow this. This is less than 2. We put it here, and we understand that we are done because this is less than 2, or the base. And the binary system, the binary representation will be this. But as we said, from the bottom up. See here? It says all remainders bottom up. So starting from here, number 13 would be 1, 1, 0, 1. If we want to verify that, let's try to convert it back to decimal. We know that this place value is 1, this place value is 2, this place value is 4, and this place value is 8. So 8 plus 4 is 12 plus 1, that equals 13. Now, at this point, we have reached the end of our tutorial. I'll see you guys. Thank you so much for watching, and I'll see you in the following tutorial, which is part 2 of binary system. Thank you.